Greetings, welcome to this new video about mesh analysis method. Solve the problem number 10. In this video I will show you how you can derive by inspection the mesh current equations, and I will show you how you can solve that using MATLAB. Remind, this method is valid only when resistive circuits contains only independent voltage sources. Given the electric circuit consisting of 10 resistors labeled R1 through R10, as well as 4 independent voltage sources VA, VB, VC and VD. The question now, by inspection, find the mesh current equations and determine the mesh currents. Let's move on to the solution. The mesh current equations are given in matrix form as follows: R I is equal to V. In this circuit we have 5 meshes, so the dimension of the resistance matrix is 5 by 5. I present the vector of the unknown mesh current in the clockwise direction, and V is the input voltage vector which has the terms in volts. This is our resistance matrix R. Let's start first with the diagonal terms of R. R11 is the sum of the resistances in mesh 1. This is our mesh 1 is equal to R1 plus R2 plus R3. We get 9. Let's move on to R22 is the sum of the resistances in mesh 2 is equal to R2 plus R4 plus R5 plus R6 plus R7. We get 10. We go now to R33 is the sum of the resistances in mesh 3 is equal to R3 plus R5 plus R10. We get 9. Let's go to R44 is the sum of the resistances in mesh 4 is equal to R6 plus R8 plus R9. We get 8. Let's move on to the last one. R55 is the sum of the resistances in mesh 5 is equal to R7 plus R9. We get 4. We go now to the off diagonal terms of R. R12 is equal to R21 is the negative of the sum of the resistances in common with meshes 1 and 2. This is mesh 1 and this is mesh 2. The common resistance is R2. Then we have negative R2 is equal to negative 2. R13 and R31, this is mesh 1 and this is mesh 3. The common resistance is R3. Then we have negative R3 is equal to negative 2. We go to R14 and R41. This is mesh 1 and this is mesh 4. There is no common resistance, so R14 is equal to R41 is equal to 0. Let's move on to R15 and R51. This is mesh 1 and this is mesh 5. There is no common resistance, so is equal to 0. Let's move on to R23 and R32. This is mesh 2 and this is mesh 3. The common resistances are 5. Then we have negative R5. We get negative 4. We go to R24 and R42. This is mesh 2 and this is mesh 4. The common resistance is R6. Then we have negative R6. We get negative 1. We go to R25 and R52. This is mesh 2 and this is mesh 5. The common resistance is R7. Then we have negative R7. We get negative 1. We go to R35 and R53. This is mesh 3 and this is mesh 5. There is no common resistance. Then we have 0. We go to R34 and R43. This is mesh 3 and this is mesh 4. There is no common resistance, so R34 and R43 is equal to 0. Let's move on to the last one, R45 and R54. This is mesh 4 and this is mesh 5. The common resistance is R9. Then we have R9 is equal to negative R9 is equal to negative 3. Now let's move on to the input voltage vector V. We start first with V1. Is this sum taken clockwise of all independent voltage sources in mesh 1 with voltage raised treated as positive. Let's start first with mesh 1. We have only VA as an independent voltage source. If we go in the clockwise direction, then we have voltage raised, then V1 is equal to VA is equal to 4. Let's move on to mesh 2. We have two independent voltage sources, VA and VB. If we go in clockwise direction, here we have a voltage raised and here we have a voltage drop. That means VB minus VA is equal to 10 minus 4, we get 6. Let's go to V3. We have two independent voltage sources, VC and VT. If we go in the clockwise direction, we have here in VC we have voltage raised and in VD we have a voltage drop. That means V3 is equal to VC minus VT. We get 6 minus 12, we get negative 6. Let's go to V4. In mesh 4 we don't have any independent voltage sources. That means V4 is equal to 0. Let's move on to V5. In mesh 5 we have only one independent voltage source. If we go in the clockwise direction, we have voltage drop. That means V5 is equal to negative VC is equal to negative 6. After we apply the mesh analysis by inspection, we obtain our matrix resistance R and our input voltage V. Since this problem is quite difficult to solve, I created a MATLAB program that makes it easier to solve, which given with this picture. Let's go through this program. We have R is our resistance matrix, V is our input voltage, and I is our mesh current vectors. Let's start first with the resistance matrix R. This is our row number 1, row number 2, row number 3, row number 4, and row number 5. We can see here that the rows are separated by a semicolon. It's also the same for the input voltage vector V. We have row number 1, row number 2, row number 3, row number 4, and row number 5. And the rows are also separated with the semicolon. I is equal to ln_solve RV. Ln_solve is a function used to solve linear equation in matrix form. After we run this program, we obtain the values of the mesh currents. We have here I1 is equal to 382.9 milliamps, I2 is equal to 211 milliamps, I3 is equal to negative 487.8 milliamps, I4 is equal to 718.4 milliamps, and I5 is equal to negative 1.98 amps. After we finish our simulation in MATLAB, we go now to verify our results using SPICE simulator. This is our circuit done by SPICE simulator. We have here our I1, R2 is the current through the resistor R2, and R8 is the current through the resistor R8, R5 is the current through the resistor R6, and we have I4 and we have I3. Let's go to analysis, DC analysis, table of DC results. Let's start first with I1. I1 is equal to 382.95 milliamps, is almost the same value we obtained by calculation. Let's go now to I3. This is I3 is equal to negative 487.7 milliamps is almost the same as the result we obtained by MATLAB. Let's move on, for example, to IR8. This one is equal to I3 minus I1. I3 is negative 0.4878 minus 0.3829. We obtain negative 870.72 milliamps. Those values are exactly the same value we have obtained by calculation. So thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another example about mesh current method. Have a nice time. Bye bye.